Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science from 2024, Paper 1, Higher Tier Physics. Question number 3 is on the topic of electricity. A student investigated how the current in a red LED, right? Let me redraw that line. So, current in a red LED varies with the potential difference across the LED. Figure 3 shows an incomplete diagram of the circuit used. So here you have the battery. It's not a cell because there's more than one. The switch, the LED, and this is the variable resistor. So let's have a look at the first part of the question. Complete figure 3 to show how the student should have connected a voltmeter and an ammeter to the circuit. Use the correct circuit symbols. So if you want to measure the current, you need to add an ammeter which should be in series to the LED. So the ammeter should go in series or anywhere along the line in the wire. The position of the ammeter doesn't actually matter. Now, the voltmeter, because you're trying to measure it across the LED, you have to connect it across the LED. That's your voltmeter. Each of them carries a mark. The potential difference across the battery was plus 2.6 volts. The student varied the potential difference across the LED between minus 2.6 volts and plus 2.6 volts. Describe how the student should have adjusted the circuit to vary the potential difference across this range. Now, 0 to plus 2.6 volt, she can adjust the variable resistor or she can change the number of cells. So let's describe it in two parts. From 0 to plus 2.6 volts, right? Either adjust the variable resistor or add, or you could say remove the cells, right? Now from 0 to minus values, right, to get negative values, reverse the connections to the LED or the battery. Next question. Table 1 shows the results when the potential difference across the LED had positive values. So you're starting at 0 and ends up at 2.6. Current in milliamps goes from 0 to 69. Figure 4 shows a graph of current against potential difference. Complete figure 4, plot the remaining points from table 1, draw a line of best fit. So here you can see that they have plotted 0 plus 1 or 1 and then 1.6 They have done it as well. So that's your third point. The next one is at 2. At 2 volts, the current is 5. So this is 10. So it should be halfway through there. And then at 2.2 volts, so that's 0.1, 0.2. Okay, so 2.25. So this is 2.2. It's 19. Goes up to 10. 19 is halfway there. Oops, slightly off. Let me get that off. So 2.2 is actually, yeah, so that's 19. And then at 2.4, which is 2 boxes before this, it's 41. 41 is halfway to the point. And then at 2.6, it's 69. So that's 70. 2.6 or there. So you should be drawing a smooth line. Now on this, it's going to be a bit difficult. Hopefully I can get it now. Oh, there we go. Right, and it would go all the way up to 0. Explain what happens to the current in the LED when the potential difference across the LED is negative. Now, when the potential difference across the LED is negative, the current is going to be 0. Why? Because the LED is similar to a diode, which has high resistance, right? So it doesn't let current go through in the negative direction. So the current is 0 because the LED has a very high resistance in the reverse direction. A second student did the investigation using a blue LED. The results for both the red LED and the blue LED show the same pattern. What conclusion can be made about the investigation? Now, if you are getting the same pattern, is it repeatable or reproducible? Now, if you're getting the same pattern, then you actually it's reproducible. The relationship between the current and potential difference for an LED is non-linear. It's not a straight line. Which of the following always shows a linear relationship between current and potential difference? That would be a resistor at constant temperature. Remember, there are 3 graphs. For a resistor, the IV graph should be a straight line like this. For a filament lamp, the IV graph is an S shape. Now, for an LED or a diode, which is all similar, an LED is similar to a diode, the graph is going to be like that. Now, for a light dependent resistor and a thermistor, that doesn't the current and doesn't affect the resistance here. It's actually the light, and in a thermistor it's the temperature that affects the resistance. That brings us to the end of question number 3, and I will see you in question number 4.